Rust ensures most of code bugs are caught at compile time. Yet, there's a class of hard to spot bugs which are not even mentioned in a warning. Fortunately, there's a proposal to fix this situation. As usual, let's first define the problem. Let's consider such innocent code. Let's consider two functions. Foo, which takes one parameter, and bar, which also takes the same parameter but wrapped in a mutex. Inside, let's simply unwrap, lock the mutex and unwrap the result and call foo. We're not interested in any error handling here. And now foo with widget. We have a very simple pattern. A mutex gets locked and the wrapped value is passed to another function. Nothing wrong here, everything works as expected. So let's now modify the code a little. What we need to do is add async here, and simply await the result here. At first glance, nothing major happened. Everything builds just fine. Let's confirm, no errors, and the code seems to do the exact same thing as before. Yet it contains a hidden major bug. A bug which can bring down the whole process. The issue lies in awaiting for the foo function to complete, right here. If there are other tasks queued in our async executor, another one might jump onto the current thread. If the task tries to lock the same mutex, like we do here, we'll get a classic deadlock. Remember, you can think of await as arbitrary code being executed in this very place. What's worse, if there are tasks on other threads trying to lock the same mutex, they'll get deadlocked too. And suddenly the whole process freezes. Again, without any warning. Such bugs can be hard to spot, especially when migrating to async from synchronous code. So, how to deal with it? Right now, there's not much we can do. But fortunately, we have a pending RFC to help such situations, YieldSafe. YieldSafe would be a default auto trait, just like sync or send, and would be required for types to cross yield boundaries as awaiting. With that and the possibility to add negative implementations, we could mark types as sync mutex as not safe to use in an async context, while more formally, a mutex guard. This would prevent such bugs in a general way. In our example, if the mutex returned by the lock function would cross await, the compiler would generate an error. I encourage everyone to take a look at the RFC and share your opinions. Okay, so now I hope you know what the problem is with synchronous types crossing yield boundaries. Hope you found this informative, hope you found this interesting. Leave your comments down below, keep subscribed, and I'll see you in the next one.